To support cancellation of async tasks, a cancellation token source and a cancellation token are used. A cancellation token source is an object which manages and sends cancellation notifications to the individual cancellation tokens. It exposes such a cancellation token via its token property. That cancellation token is a lightweight value passed to one or more listeners, typically as a method parameter. Listeners should then monitor the value of the isCancellation_requested property of that token and react accordingly. From that, it follows that a cancellation token is what we need to pass to each task returning method we want to listen to cancellation. So, the idea is that we provide these cancellation tokens to whichever part of our application we want to listen to cancellation and cancel itself. And we use the cancellation token source to effectively request them to cancel themselves, which it does by sending notifications to those tokens. To make this a bit more tangible, let's go back to our movie trailer example. If we want to cancel the downloading of a movie trailer whenever the user navigates away or for whatever other reason, we need to be able to pass a token to our HTTP client. You'll notice that the common methods we use for interacting with an API, like sendAsync, allow us to do that. When we call cancel on the cancellation token source that the token is related to, our HTTP client will be notified of this. That doesn't mean that the download is cancelled then. It's HTTP client that takes care of this. So HTTP client listens for cancellation and it will not send a request if cancellation has been requested. Let's have a look at the demo. In this demo, we will learn how we can request cancellation of a request. We're going to do that in the cancellation samples class. Let's start by injecting the factory and options. There we go. Then let's add a new method. GetTrailer and CancelAsync. I pasted it in as it's pretty much a copy of what we did when getting a poster. We create a new GET request, this time to trailers. We use gzip compression as it's more efficient than not using compression, and we use a stream as that's the best practice. Let's import the necessary namespaces, system.text.json and movies.client.models. That's it for our method. Nothing new here. Now let's support cancellation. The first thing we want to do is instantiate a new cancellation token source. So we new one up. From this source, we can then pass through the token when we send the request. Like this, HTTP client can listen to cancellation. There's an overload for the sendAsync method available for that. So we pass through cancellation token source.token. Lastly, we need to actually cancel the request. As we learned, you would typically do this when the user navigates away or presses a cancel download button or something along the lines of that. On the cancellation token source, there's two methods we can use to effectively send a request for cancellation. Cancel will immediately ask for cancellation, while cancel after will do so after a specified amount of time. For the demo, let's use that one. We'll cancel after, say, 200 milliseconds. Alright, let's make sure we call this method when we run the application. So in the runAsync method, we await GetTrailer and CancelAsync. And in the program class, we ensure that the cancellation samples class is registered on our container. There we go, let's give this a try. And we hit an exception. But this is actually a good exception to hit. It's a task cancelled exception, stating that the operation was cancelled. This is what HTTP client throws when it has cancelled the request. So far, so good. Cancellation works. But is this a good place for initializing the cancellation token source? By which I mean in the method itself. Let's have a look at that in a bit more detail in the next demo. Let's look back at our code. We're instantiating the cancellation token source in the scope of the getTrailer and cancelAsync method. That's okay for demo purposes, but typically you want to be able to pass the token to different concurrent requests to allow canceling all of them in one go. Next to that, you often want to access that cancellation token source instance from other parts of your application. For example, to cancel when the user navigates away or presses a cancel download button. So, to make this a bit more realistic, let's put the initialization of the token source outside of the method. So let's get rid of this. And let's add a new field to our cancellation samples class in which we store the cancellation token source after newing it up. Then we need a way to pass through the token to our method. So we have our getTrailer and cancelAsync method accept a cancellation token. There we go. And it's then this cancellation token that we pass to the sendAsync method. Lastly, we need to cancel. So in the runAsync method, or in any other method in your application that you want to trigger cancellation requests from, we call cancelAfter on the cancellation token source. And we pass through the token to the getTrailer and cancelAsync method. There we go. Let's give this a try. We again hit our task cancelled exception, so this still works as expected. But this time with code that's a bit more realistic. We still need to handle the exception that happens on cancellation though. Let's have a look at the next demo for that. In this demo, we will learn how to handle a cancelled request. It's actually pretty straightforward to do this. As we noticed, cancelling a request makes the client throw an exception, a task cancelled exception to be specific. It's this type of exception we want to catch, or rather its base type, the operation cancelled exception, which makes us slightly more ready for future changes. So we add a try catch statement. What we want to catch is an operation cancelled exception. And let's write out the exception message to the console output window, so we can see what happens. What you need to do in the exception handler depends on your use case. You might need to clean up additional resources you no longer need. You might want to navigate to another page. You might want to show an error to the user in some cases. It really depends. What you could also do is catch the exception somewhere higher up in your code hierarchy. All of that depends on how exactly you are implementing your application. The important thing here to remember is that we catch the exception so we know what happened, being the fact that the operation was cancelled, and we can act accordingly. Let's give this a try. And there we go, we caught our exception. There's one more use case to look into. As we learned, cancellation also happens when a request times out. Let's have a look at that. In this demo, we will learn how to deal with timeouts. As we mentioned before, HTTP client will cancel the running task when a timeout happens. So let's see how that works. We'll add a new method, getTrailer and handle timeout, async. In this method, we send a request to getTrailer and we read out the response. There's no cancellation token source nor token used, but we do catch the operation cancelled exception. So the content here is a copy of our getTrailer and cancelAsync method, but without using a cancellation token. Let's make sure this method is called when we run the application. There we go. Alright, but what about that timeout then? Let's open the program class. Here we configured our Movies API client. We can set a timeout value here. It's currently set to timeout after 30 seconds. Let's change that to 1 second. And let's give this a try. We don't see any cancellation happen. Apparently my computer is a bit too fast, as it only took about 700 milliseconds for this request to finish. So let's change the timeout value. Let's make sure the request times out after 200 milliseconds. And let's give that another try. And there we go. Our operation was cancelled, but this time due to it timing out. So, even without explicitly asking for cancellation, we can hit an operation cancelled exception. That means we must prepare our code so it can catch these types of exceptions and act accordingly. There's more information on how to do all of that in the next module. For now, let's set the timeout value back to 30 seconds and let's have a look at the module summary. Cancellation is important. Cancelling a task helps free up threads that are no longer required. Next to that, HTTP client will cancel the request itself when a timeout is reached. To allow cancelling a task, we pass through a cancellation token when making our request. The moment we call cancel on the cancellation token source that produced the token, we signal HTTP client that it should effectively cancel the request. Once that happens, a task cancelled exception is thrown. The same exception is thrown when a request times out. To handle that, we can catch that exception, or better, the more wider purpose operation cancelled exception. But that's not all there is to handling faults and errors. Let's continue with that in the next module.